Okay, this today's the entire lecture is based on this only curl, gradient divergence curl. Yesterday in the last 15 minutes, session, I have given you some idea. Okay, let me recall that idea. Okay, I want to let me recall the same idea like 15 minutes. Let me give the same introduction. Okay, guys, because today's topic is all about curl, divergence, and gradient. What just recall whatever I told you yesterday. What is a gradient means? A gradient means the two things are there. Okay, it will tell you the maximum steep in the function. For example, I'm having a scalar field. For example, this is my scalar field. I'm having a scalar field something like this. This is my scalar field. Okay, the function in the scalar field. Okay, function in the scalar field. This is x, y. This is z. So the gradient tells me that the direction. Okay, because if for a particular scalar field means if I'm taking tangent means the tangent will be like there will be infinite tangent on a particular scalar field, because since it's a 2D plane. For example, take a rubber ball and take a toothpick on top of the rubber ball. If I rotate the toothpick means the toothpick will be freely rotated, right? So all the point in the toothpick will be tangent of the ball, right? So this is the surface of the ball. Okay, the toothpick, right? To change the orientation of the toothpick anywhere, everything will be tangent of the ball. So the tangent will be infinite tangents. I'll be having a infinite tangents on the surface of the ball. Okay. Now, since I'm having infinite tangent means I cannot define the tangent by a single line like our usual 1D curve. For 1D curve, tangent means simply a line passing through the point is a tangent. Okay, the tangent line. But here the tangent is not a line; it's a kind of surface. There are infinite tangents. Usually, we'll represent that by a plane, tangent plane, and all in 2D surfaces. Okay. The concept I want to give here is if I'm asking you which direction the change is maximum. Okay, if I'm asking you which direction the change is maximum means, will you do that? It's not possible, right? Because that direction information is not given here. Because here we can say based on the slope, okay, we can say the maximum changes in the direction and all is given by the slope itself in 1D. But here it's not given. Okay, so therefore we need some other information like which has to show the direction and all. That's where gradient come in place. Okay, a gradient is nothing but we are enhancing a scalar to a vector field. So I have given you one example. For example, let me take a temperature function. You know that temperature is a scalar, right? Because if you change, yesterday I mentioned you, so I'm standing on top of some kind of oven. Okay, the oven is heated to 60 degree. If I keep on rotating myself, okay, the temperature I'm experiencing on my food is 60 degree only. It won't change because temperature is a scalar quantity. It doesn't change because of the direction. Got it, right? Temperature is scalar. Now this temperature I told you, there is a room. Inside the room, this is my temperature function. So inside the room, this is my temperature function, right? Each and every position in the room has some temperatures. Okay, based on this function, I can calculate temperature on each and every position of the room. For example, based on the positions x, y, z, my temperature value. Okay, calculate the value. For example, this is where the x is like 10, y is 10, and z is 5, somewhere like this. Substitute, plug the x value, y value, z value here in this function, you'll be getting one temperature, assuming that the temperature is 60 degree. Here the temperature is 40 degree, 30 degree. So each and every point in the space you can find the temperature function. Okay. Now all the temperatures can be found based on the positions. Suppose I'm asking you, so in which direction the temperature changes maximum? When you do that using this information, using the scalar function, I'm asking you in which direction the temperature changes is maximum. If I'm asking you like that means the temperature is not a vector quantity. And now the question I'm asking you the direction. So therefore, just to take gradient of this function. If you take the gradient of this function means, so each and every point will give you one vector. Okay. If you see the vector now, for example, if you plot the vector, it will look something like this. See, it will tell you the maximum changes, where the temperature change is maximum. Suppose here the core is there. Okay. Core, core is means that's where the all the temperatures are some kind of in a nuclear core or something. Okay, nuclear plant, there is a core is there, right? From here only the temperature is going out means you will get the vector something like that outward normal. Okay, but here all the vectors are going inside, so it's telling me the direction, it's telling me the maximum changes in the temperature. That is the one property of gradient. Okay, that is one property of gradient. So how to take the gradient? For before that, I want to I'm using the del operator, right? I have to give the definition for this del operator. So this is the del operator, right? So usually the del operator is what we'll be using for all the divergence, gradient, and curl. The del operator is nothing but dou by dou x of I vector plus dou y of j vector plus dou by dou z of k vector. This is your del operator, guys. Simply. So gradient of a function f is nothing but del f. Okay, simply you have to express that as notation is del. Del f is nothing but dou f by dou x I vector plus dou y j vector plus dou f by dou z k vector. So this is the operation of gradient. So let us take the same function. Let us take the same function what we have used. Okay, f is equal to 10. F is equal to, that is the temperature function, 10 e power minus x squared plus y squared plus z squared. So this is my function means what is the gradient vector? The gradient vector is nothing but del f. Del f is nothing but dou f by dou x. So dou f by dou x of this is nothing but 10 e power minus x square plus y square plus z square into with respect to x. So therefore it is minus 2x. Okay, into I vector plus the same 10 into minus 2y j vector plus 10 e power minus x square y square z square into minus 2z k vector. So this is my gradient. You got it, right? So differentiate with respect to dou f by dou x, dou f by dou y, and dou f by dou z. So this is my gradient. So that's what I've written here. Okay. So gradient means simply take del f, that will give you a, so see that what is happening in the gradient. A scalar quantity is, this is a scalar quantity. The scalar quantity, right? Scalar quantity. It is enhances to a vector quantity. That is the property of gradient. Okay. So gradient, one property is it will tell you the maximum change in the direction. Okay, the direction where the maximum changes happens. Okay, that is the first property of gradient. The second property of gradient, geometrically, what it tells means, if I'm having a surface, this is my tangent plane of the surface, for example. Okay, tangent plane. The gradient will give you the normal, exactly the normal of this tangent plane, perpendicular to the direction perpendicular to the tangent plane, which means surface normal. You can say two things. Okay, the gradient will give you the surface normal direction. Okay, guys, you got it, right? First property of gradient is like one property of gradient. It will tell you the direction in which the maximum changes happen. Okay, but geometrically, if you see the surface point of view, means the gradient will give you the direction of surface normal. Okay, so note down this point. This is very intuition. Geometrically, just